Hi, today we're going to work on analyzing parabolas, and we're going to discuss the direction that the parabola opens, its vertex, whether or not it has a maximum or a minimum, its axis of symmetry, and its zeros. So even though this particular packet doesn't have a place for your name, let's make sure that we put it on there at the very top, so that your work is always known to be yours. Let's look at example number 1. Hopefully by this point in our series of parabolas and quadratics, much of this information is becoming very rote, very understood with clarity and without need for definition or more explanation. The one topic that I am going to make sure that I spend time on very briefly, actually two of them, is the axis of symmetry and the zeros. These two items right here. So let's make a note. We have lots of room on this paper. Axis of symmetry. The axis of symmetry, it is always an equation. It is never just a number. It is also always an equation where it is x equals some number. It's a very simple equation, but you need to know that it is an equation. And finally, we abbreviate the axis of symmetry as the AOS. All right, the second thing that we need to just clarify is the word zeros. Zeros is one of 4 names for the exact same thing. Zeros, x-intercepts, roots, and solutions mean the exact same thing. So depending on the writer of a particular problem, text, or state test, they will interchange these 4 terms and expect you to know that they mean the exact same thing. So now that we have that, let's go to work and knock this out. Problem number 1. We are given a graph. Great. So very quickly, hey, which direction does this open? Oh yeah, it opens up because the arrows are pointing up. Great. Now, the vertex. Your vertex is a coordinate point, and we're labeling here on our picture. This is my vertex. So the address of that particular coordinate point happens to be 1, 2, 3 spaces to the left, -3, comma, up nothing, 0. So it's the coordinate point, -3, 0. Maximum versus a minimum. So is this a maximum mountain? Does it make a mountain shape? Or is this a minimum valley? If it makes a mountain, you've got a maximum. If it makes a valley, you have a minimum. This is a valley. It is a minimum. All right, the axis of symmetry. So we just stated a few moments ago, definition of the axis of symmetry is always an equation of x equals. X equals what? The axis of symmetry is where you can fold your parabola perfectly in half, and it goes directly through the vertex. So its number, x equals, is always the x part of my vertex. So x equals -3. And finally, my roots, my x-intercept. In this particular problem, there's only one of them. You might have none of them. You might have one, or you might have two. It just depends on where the parabola is located on the coordinate plane. This particular quadratic only has one. It only touches the x-axis at one point, and it happens to be at the same place that my vertex is. So my 0, my x-intercept, my root, my solution, is the coordinate point -3, 0. That was easy. Yeah. Let's go make sure we really know how to do this. And let's look at example 2. All right, let's see what we can get done. In example 2, does this parabola open up or down? You tell me. You're right, it opens down. So where is the vertex located? Can you draw an arrow to it? Great, this is the vertex. What's the address of that coordinate point? Okay, be careful with your ordering of your numbers. It did not go anywhere right or left, so the 0 comes first this time. It did, however, drop down 2 units, so the -2 comes second this time. Remember, x and then y. Okay. Is this a maximum mountain or a minimum valley? You're right, it's a mountain. So therefore it has to be a maximum. Great, we're getting this done. So the axis of symmetry, where is that? First off, is it a number or an equation? Yes, it is an equation. Okay, so where is it located on your graph? Right through the middle, where I can fold it in half. There it is labeled. What's the number? X equals what? Good, you remembered. It's the same number as that in your vertex in the x location. X equals 0, because this is the line that we can fold it on. Now, this one's a little bit more tricky. Where is the solution? Where is the root? Does it even have any? No, it doesn't. It does not cross the x-axis at all anywhere on our graph. And so therefore, we are going to say that it has none. If it asked for the number of solutions, how many times did it cross the x-axis, that's when you would say 0. But since it doesn't ask for the number of times, you just write the word none. Okay, pause the video and you try number 3 on your own. Come and talk to me if you need a little help. I hope you did really well on number 3. Let's make sure that we have our skills down solid. Let's do number 4 together and see how it goes. Problem number 4. What direction does this open? Up or down? Down. That was fast. Vertex, where is it located? Can you point to it? Great. What's its coordinate point address? One, two, three. 3 units to the right. 4 units up. Did you put your 3 and your 4 in the correct order? I hope so. Remember X and then Y. Is this a mountain or a valley? What shape does it make? Yep, it's a mountain. So is it a maximum or a minimum? Great, it's a maximum. And you're right, it doesn't ask for it in this problem, but let's make sure that we have our practice. What's going to be the axis of symmetry? A number or an equation? An equation. X equals what equation? It's right there going through my graph. X equals 1, 2, 3. 3. The same as the 3 from my vertex. Finally, let's look at zeros. Does this particular graph cross or touch the x-axis? It sure does. It does twice. This is where the STAR test or your end of course exam will say, where is the x-intercept? And you will say, right there, right there. Okay, let's write down our 2 coordinate points. The one on the left, 1, 0. Great. The one on the right? 5, 0. Great job. Okay, pause the video. You do number 5 and number 6. Welcome back. Problem number 7. So this time, instead of giving us graphs and pictures to use, they are giving us limited information based on an equation. But they're still asking for all of the same answers. What direction does it open? The vertex, the axis of symmetry, maximum, minimum. They are not, however, asking us for zeros at this time. And that's nice. So we need to remember how to find all of those things just given an equation. All right. So if you're given an equation, the first thing you want to look at is what are A, B, and C. This is standard form. So in standard form, there's a lot of things that we can determine. But in order to find them easily, let's go determine A, B, and C from the equation first. A is a positive 1. B is negative 4. And C is a positive 7. Great. So we can tell that this particular quadratic is going to open in the upward direction because A is positive. Before we go find the vertex, we really should find the axis of symmetry. It'll make it a lot easier. Why will it make it easier? The axis of symmetry is part of the vertex. So let's go find a part of it first. The axis of symmetry. We discussed in a previous lesson, there's a very small little equation to help us find it. Do you remember what it was? Negative b over 2a. So we just found a, b, and c just a minute ago. Let's go plug these in. Minus b, which is a negative 4, all over 2 times a, which is 1. What's a minus and a minus side by side? Positive 4. 2 times 1, 2. And the last time I checked, let's see, 4 divided by 2 is 2. Fantastic. So now that I have the axis of symmetry, it's going to be really easy to determine what the rest of my vertex is. I know part of it is 2. These are the same. Let's go find the other part of it. Where our original equation was y equals x squared minus 4x plus 7. We're going to substitute this 2 in for both of those x's. 2 squared minus 4 times 2 plus 7. Let's go put this in your calculator and see what we get. Always push no, not going to save. I for sure need a calculator. Let's type this in. 2 squared minus 4 times 2 plus 7. Did you get 3? If you did, good job typing that in correctly. So that tells us now our vertex is the point 2, 3. All right, we have one more piece of information on this problem that we have to answer. They're asking us if our graph is a maximum or a minimum. Well, let's think about it for a minute. We know that our graph is going to open upward. So if it opens upward, it'll look something like that, somewhere on the coordinate plane. It opens up. Therefore, is this a mountain or a valley? Yeah, it's a valley. And since it's a valley, it's a minimum. Fantastic. Let's go look at number 8 together. All right, in problem number 8, we're going to start this off the exact same way that we started off number 7. They again gave us an equation to work with. So let's see what we need to do. We know that the standard form of an equation is y equals ax squared plus bx plus c. So what is a, b, and c? This time a is -1. That's different. B is -6 and C is -7. Wow, they're all negative. All right. So which one of these three letters do we look at to determine if the equation is going to go up, if the parabola is going to go up or down? A, B, or C? That's right, it was A. And since A is a negative value, then this particular quadratic will open down. Okay, we said in problem number 7 that it's easier to find the axis of symmetry first before we find the vertex. So let's go find the axis of symmetry. You have your equation. X equals, what were the letters? Minus B over 2 times A. Let's go fill in the blank. Negative B. B is negative 6 over 2 times negative 1. A negative and a negative side by side, positive 6. 2 times negative 1, negative 2. What's a positive divided by a negative? That's right, it's a negative. What's 6 divided by 2? 3. So the axis of symmetry is x equals negative 3. Great. All right, let's use that to go find the rest of your vertex. We already know part of it. We just need to know the rest of it. So our original equation, y equals negative x squared minus 6x minus 7. So here again, we have this conversation about using parentheses. They're very powerful and they're very important. So negative parentheses negative 3 squared minus 6 times negative 3 minus 7. Some people like to ask me if you need to use the parentheses as you type your equation into your calculator. You bet. Makes all the difference. All the difference of what? Between right and wrong. Understanding, passing, or not. Okay, let's type them in very carefully. Negative, not minus, not subtract, but negative, parentheses, negative 3